Yeah. Hello, friends. Welcome to my YouTube channel, Paul Mathematics Academy. Now, in this video, we have to evaluate this integral. Integral running from 0 to pi over 2, the x over 1 plus tan x raised to the power of pi. Okay, before we start, now don't forget that this is Paul Mathematics Academy channel. And don't forget to subscribe to my channel, like my videos, comment, click the notification button so that anytime we upload video you'll be the first person to be updated. And don't forget to share our videos to your friends who also like mathematics. Okay, let's get started with the solution. Now, looking at this integral, the integral load word, but it's very simple. It's very simple. Now we are to use the King's property in order to evaluate this our given integral. Now I will recall the King properties. Now these are the King properties. If we have integral running from a to b of f of x dx. Now to apply the King's property, we have integral running from a to b of a plus b minus x dx. So these are the King properties. That is, anyway we see x here, so we subtract our limits. We had our limits and subtract from this x. Okay, this is what I mean. Now let's get started with the solution. So where our a is 0 and our b is pi over 2. Okay, so we have, okay, I can call this I, so I can say I is equal to this. So I have I is equal to integral running from 0 to pi over 2 dx all over 1 plus, now we have tan of pi over 2 plus 0 minus x, so raised to the power of pi. Now I have I is equal to integral running from 0 to pi over 2 dx all over 1 plus tan pi over 2 minus x raised to the power of pi. And don't forget this trigonometry identity. If we have tan of pi over 2 minus x, it's gonna give you cot x. So we replace tan of pi over 2 minus x by cot x. So I have I is equal 0 to pi over 2 dx all over 1 plus cot x raised to the power of pi. And we recall that the cotangent of x, that is cot of x, it's gonna give us 1 over tan of x. So that is inverse of tan x. Now I have I is equal to integral running from 0 to pi over 2 dx all over 1 plus, so we have 1 over tan x raised to the power of pi. Okay, so now my integral becomes integral running from 0 to pi over 2, so dx all over 1 plus, that is 1 over 1 raised to the power of pi is 1, so 1 all over tan raised to the power of pi x. So our integral is now transformed to integral running from 0 to pi over 2 tan raised to the power of pi of x all over 1 plus tan raised to the power of pi x dx. So I call this b. So I call my initial integral a. So I call my initial integral a and I call my second integral b. Now adding the both integral, so we have adding a and b. That is, we are adding the two integrals, this integral and this given integral. So we are adding them together. So I have I So I have I plus I is equals to integral running from 0 to pi all over 2 dx all over 1 plus tan raised to the power of pi x, okay, plus integral running from 0 to pi over 2 tan raised to the power of pi of x all over 1 plus tan raised to the power of pi of x dx. So adding the two integrals together, okay, so I plus I, that's 2i, so I have 2i is equal to, so they have the same denominator, so we had the what, the numerator, so I have integral running from 0 to pi over 2 1 plus tan raised to the power of pi of x all over 1 plus tan raised to the power of pi of x dx. So these and these give us 1, so I have 2i raised to the is equal to integral running from 0 to pi over 2 dx. So integral of dx will just give us x, so I have x running from 0 to pi over 2. So applying my limits, so I have 2i is equal to pi over 2, so divide both sides by 2, so I have I is equal to pi over 4. So therefore the integral running from 0 to pi over 2 dx all over 1 plus tan raised to the power of pi of x is equal to pi over 4. So if you like this kind of video, please don't forget to subscribe to our channel. Thank you, and share my videos to your friends who also like mathematics. So this is what we call using the king's rule, the king's property. Yeah, God bless you all. I like you. Thank you.